Calcium is often forgotten as a nutrient. In this portion of the video, we'll explain to you how it functions in the plant, how it functions in the soil, and how it can help with nutrient uptake. Calcium is a crop nutrient. Calcium is a strong cellular regulator in the plant. It controls 9 other nutrients, their inflow into the plant. So while we did talk pH and having pH in the right range, we also want to look at our soil tests and make sure calcium is high on the report. Calcium makes stronger cells, and if you've driven up and down the road, you've seen the SDS and some white mold. Particularly white mold will attack the plant on a cellular level and break down the cell. As that fungus attacks the plant, the calcium's pumping more, or the plant's pumping more calcium to that cell to basically put a scab over it to keep the fungus out. Well, if you don't have enough calcium in the plant, in the soil, it can't heal itself. The diseases take over and kills the plant. The other important thing about calcium is it's different than nitrogen. If you run it short of nitrogen on your corn over the season, towards the end of the season, it'll pull nitrogen out of the lower levels of the plant and move it to grain fill. It doesn't do that with calcium. Calcium flows with water in the plant, and so wherever it ends up is where it stays. It does not translocate out of old tissue into new tissue. You have to have a constant, readily available source of calcium throughout the plant to maintain plant health. Calcium's, again, we talked calcium, how it affects 9 nutrients. One of them is potassium. This is an old study, but you can go to our website and find it. They did a study where they applied potash at high rates, calcium at high rates, and pellet lime and potash together. And they saw a 13 bushel increase using smaller rates of potash with a smaller rate of pelletized lime. You'll read all the time where the universities say, be careful going out with a lot of lime because you'll drive your potassium levels down. And that may be true, but they don't really have a definitive mechanism for why that is. They can't really tell you why that is. We think it's when you go out with 2 to 5 tons of ag lime, you're putting so much calcium out there that you're basically drowning out the potassium. And so the plant's not uptaking as much potassium. But there are tons and tons of studies that go back and show that applying calcium with potassium increases your potassium uptake. And why they think that is having extra calcium out there helps that plant uptake more nutrients. It helps build stronger, bigger roots on the plant, so you access more of the soil. There's a picture from one of our customers that does a field day every few years on a root dig. Having that adequate calcium really helps the potassium exchange off the soil particle and get into the plant and helps build stronger plants. Anybody have an idea what crop nutrient that is? That's a crop nutrient in its pure form. Phosphorus, it's pure phosphorus. And in the presence of oxygen, when it's not tied to another molecule, it spontaneously combusts. So everybody worries about phosphorus tie-up and how do we make phosphorus more available? And the short answer is it's really tough because it's going to always tie up with something. So do you want that to be tied up with calcium, where it will actually break down over time and be more plant available? Or if your calcium's low, it's going to attach to aluminum, because as your calcium drops and your pH drops, you make aluminum. Aluminum becomes more available, and aluminum ties up phosphorus at an extreme rate. So we want to make sure we have lots of calcium out there so we don't get into a problem where aluminum becomes more available, because aluminum is extremely toxic to your plants. This is a healthy root tip. This is a root tip growing in the presence of aluminum. So if your calcium's low or your pH is low, aluminum becomes more available, and it just stunts the roots. And if your roots aren't growing, you're not taking up water, the plant's not respirating, it's not bringing nutrients in the plant, you're not filling grain. Going back to the roots again, healthy roots versus unhealthy roots. Your corn roots should always be bright white. That's a good indication that your pH is good, your calcium levels are high. Lots of other crops, fruits and vegetables especially, you can find all kinds of studies that link calcium to root health and lower incidences of root diseases when calcium is high. So keeping calcium high in your soil is going to keep, and available in your soil, is going to help fight off root diseases. Don't see this much in Iowa, but you can. This is a field with severe calcium deficiency. A lot of people will mistake that for herbicide injury. And in fact, having adequate calcium in the soil and having adequate pH can actually make your herbicides work better. A lot of our dealers report that their soil applied grass herbicides hold much longer and they don't have as many escapes. Here on your soybeans, and you see new tissue with the leaves going necrotic and curling. It's also a good sign of calcium deficiency. The easiest way to know if your soils are short of calcium, though, is if you have surface ponding and compaction. Just on Monday, the Iowa Soybean Association said their two biggest problems in Iowa: sudden death syndrome and compaction. We can buy rippers and we can go out and rip the soil all we want, and that's a mechanical change. But if we don't add some type of different chemistry to the soil to change it, as soon as you drive through it with a grain cart or tractor or combine, that soil is going to compact right back together. You know, if you think about making homemade bread, you can mix all those ingredients all you want, but it's a chemical change that makes it rise. And once it's cooked, if you go in and squish it down and you try and pull it back apart, it's never going to be as fluffy and as mellow as when that yeast, that biology, made that soil fluffy. Another good way to check compaction is to take a shovel out, dig a hole, stick the knife in the sidewall and pull it up. And where the knife stops, that's where your compaction layer is. So to bust up compaction, you will need some mechanical tillage to speed that soil breakup, but you also need to come in with a good calcium fertilizer, either pelletized lime or pelletized gypsum, to change that soil chemically, keep those soil particles separated so it doesn't go right back there the next year. This picture was taken in Nebraska, and there are different management zones. This is obviously a seed corn field, and that's a tilled garden. What's important to know is that as you build those calcium levels, you're going to make those soil particles separate. And this is under a microscope of a soil sample, one treated with calcium, one treated with magnesium. Excess magnesium in the soil acts like sodium, and it's going to bind and make your soil tight and sticky. Go back to the previous slide of that field in the garden. Our organic matter is much higher in the field, which will also help reduce compaction if we can keep our organic matter high. But pH also is going to have a big impact on that. We're at a 5.0 pH in the field. What's important about that is when you come down to your base saturation of your cationic nutrients, you've got 41% of those nutrients are hydrogen. Out of those 5 nutrients up there, potassium, magnesium, calcium, sodium, and hydrogen's the one that's not going to make any more yield. Having low pH really impacts how much nutrients those plants can take up. And so as you reduce your hydrogen and build your calcium, you're going to build more yield. Going back to compaction, this was some end rows of that field. This is out in the middle of the field, and that was that garden. When I took those pictures, I was a little heavier than I am now, but figuring the mathematics on it, there's over 700 pounds per square inch on that end of that shovel, and jumping up and down on it wouldn't go in the ground more than 3 or 4 inches. Corn plant does not grow through soil that is denser than 300 pounds per square inch. So if you can't get a shovel in your ground, or where the shovel stops, that's where your corn roots are going to stop, and that's all the deeper they're going to go. So, you know, in particular, this farmer is only farming 4 inches of that field, where if he would rip, fix his pH, build his calcium, he could be farming 12, 36, 48 inches deep. If any of you guys have runoff problems, erosion problems, calcium is strongly linked to that. You know, this was a rainstorm that 2.5 inches in a couple days, and those particles stay intact when you have good soil health, when you have good pH, good calcium. They stick together, and the important thing is when your soil's eroding, that's where all your phosphorus is going with it. Phosphorus ties to the soil, runs off the field. When you have ponding like this, you may not think that's a big deal, but when you have ponding for more than about a day, the biology in your soil, it starts breaking down the nitrogen in your soil and pulls the oxygen off those nitrogen molecules to breathe, and all the nitrogen you put out gases off. It's denitrification. So poor water infiltration does cost you money, and you'll have to raise your nitrogen rates to account for that. As we fix our pH, build our calcium levels, reduce compaction, we're going to grow a much bigger, healthier plant. This was dug out of western Iowa last fall. If you go to our website, you can actually watch the video. They had a tile spade, and in one step sunk it all the way into the foot peg, popped the plant out, and those roots extended over 4 feet. I've never seen anything like it. That's what's going to make you bushels. The bigger your root system, the more bushels you're going to grow.